We're going to do some word problems today with systems, and as you watch the video, you can work through these problems. So the first one, we always see these different social media questions and people argue over the results. So I'm going to give you some knowledge of how to know how to solve those type of problems, and so you won't look like you're foolish to the rest of your friends and the world on social media. So under each of your problems, you're going to show your work. There's a place for you to show your work. You're going to show what variables you're going to use and what you're using them for, the equations that you're going to use, and then your answers with clear units, like what they represent. So we're going to do the first couple, we're going to do them all together, but we're going to talk a little bit more about how to find variables. So we have a mystery box. It contains 22 tickets. Some are adult tickets. Okay, so we have some adult tickets, and some are child tickets. So we have two different things we're talking about, adult tickets and child tickets. Adult tickets are worth $5 each, and child's ticket is worth $3 each. If the total value of the ticket is $74, means all that you sold, how many of each type are there in that box? So think about what we're working with. We're working with two different things. Now, if you're working with adult tickets, so let's say we're going to have one variable stand for adult tickets, the number of adult tickets, and one for child tickets. We could use A for adult and C for child, or you could use X for adult and Y for child. It's your choice. A lot of times I like to use the variables that kind of relate to the story, A and C, to kind of help me at the end know what each of them mean. So we could use X and Y. So for this one, we'll use X and Y. And we're going to talk about our first equation. So our first equation, we need something about the total number of tickets. Well, we have 22 total tickets. So we know we're going to have 22, something equaling 22. So think about what makes up those 22 tickets. Well, adult tickets and child tickets. So we have some X plus some Y make up those 22 tickets. Now, let's talk about how much they're worth. Every adult ticket was worth $5 each. So per ticket or each tells us that's like the rate of change. For every adult we sell, it's $5 more. So remember our adult, we're using X, so 5X. And then what about our child ticket? Well, we have $3 each. So for every Y, it's $3 plus 3Y. And that total is how much total money we collect. So the first equation is for total number of tickets, the amount of tickets, and the second equation is for the amount of money. Okay? So now we're going to use a way to solve for systems. So neither one of these are in Y equals, so we need to get a single variable alone. So maybe we decide to, solve for X. That's what I'm going to do. You may decide to solve for Y. So I'm going to change this one to be a single variable. So Y equals negative X plus 22. So now this is what I'm going to use to sub in to the other equation. So here's what my work should look like. 5X plus 3 times Y. Well, every time I see Y, I'm going to plug in my substitute, negative X plus 22 equals 74. You're going to distribute. We would distribute here, here. So you have 5X, and this is a positive and a negative, so negative 3X. And then 3 times 22, well, 20 times 3 is 60. 2 times 3 is 6, so this is 66. Equals 74. Combine your like terms, so I have 5X and negative 3X, so I really have 2X's plus 66 equals 74. I want to get my constants to one side and my variables with their coefficients to the other side, so I'm going to subtract 66 because it's being added now, do the opposite to move it. They cancel out here. We have 2X. And 74 minus 66 gives us 8. Divide by my coefficient of 2. And I have X equals 4. Well, what was 4 representing? What was X representing? Well, X was adult tickets. So that means I have 4 adult tickets. And how many children's tickets would I have? Well, if I told a total of 22 and I had 4, I can plug that 4 back into my equation and solve for y. I would have 18 child tickets. So from here on, I'm going to talk to you about how to define your variables, set up your equations, but then the work will be on you. All right, let's look at this second one. We have coins. So we have 19 coins worth $1.25. So immediately we know we're going to have something with the total coins of 19 and something equaling $1.25. All coins are either dimes or nickels. Oh, goodness, that's great because that's only 2 things to deal with. So the first variable we're going to use, maybe we use D, and we're going to use it to represent the number of dimes. And then the second one we'll use N and let it represent the number of nickels. So let's make our first equation. Maybe we'll talk about our total. So we have 19 total coins. Well, what makes up those coins? Well, dimes and nickels make up those coins. So some dimes and some nickels make up a total of 19 coins. And now let's talk about money. Well, we know we have $1.25 total, and it's made up of some dimes and some nickels. But how much are dimes and nickels worth? Well, every dime is worth 10 cents. Don't put a 10, but it's 0.10. Plus a nickel is 0.05. Don't confuse putting 0.5, that's actually 50 cents, as 5 cents. Okay? All right, so we know that for every dime it's worth 10 cents, every nickel's worth 5 cents, but the total is $1.25. Now, we need to solve a variable and get it alone. So let's say we solve for the dimes. So we can change this equation into D equals, when we move that N over, it turns negative, so 19 minus N. We're going to use this to substitute in the other equation. So when we solve that, we would have 0.10. Oh, there's a D. So everywhere we see D, we're substituting in 19 minus N plus 0.05 N equals $1.25. You are going to do your distributive property and then solve. You'll be solving for N. That'll tell you the number of nickels. Then you can plug back in and find the number of dimes. So when you're finished with this answer, you should have whatever number dimes, whatever number nickels. So proper unit, I should see whatever the number is you get dimes and whatever the number you get for nickels. Don't just put regular numbers. I won't know what that means. All right, let's talk about Farmer Dale. So Farmer Dale saw some chickens and some pigs in a field. All right, so we're talking about chickens and pigs. He counted 60 heads and 176 legs. Determine how many chickens and pigs he saw. So we want to know how many chickens were out there and how many pigs were out there. Now, we're going to assume that this farmer doesn't have any double-headed chickens or single-legged pigs. They're all normal chickens and pigs. So we're talking about 2 things. So we're going to use C to represent the number of chickens. And we'll use P to represent the number of pigs. So now we're going to look and see we've got a total of heads and we've got legs. So we need to know based on heads. Well, how many heads does each chicken have? Just 1. How many heads does each pig have? Just 1. So our total heads is 60, and that's made up of chicken and pig heads are 60. So that's our total heads. Now let's talk about legs. We have a total of 176 legs out in that field. So let's think about chickens. How many legs does a chicken have that they walk around on? Well, they only have 2. So we have, for every chicken, we have 2 legs, 2 per chicken. Every pig has 4 legs. So now we have our 2 equations. Let's decide which one we want to solve for. I don't see a single variable already solved, so let's pick one. I'll go ahead and pick chickens. So now we're going to change this equation over. So C is going to equal 60 minus P. Now you have something to use for your substitution into your second equation. So we would set our problem up as 2 times 60 minus P plus 4P equals 176. When you solve this one, you're going to get the number of pigs there are, and then you can plug it back in to find the number of chickens. All right, let's talk about the restaurant. So a restaurant needs to order some stools and chairs. So we're talking about stools and we're talking about chairs. Each stool has 3 legs. That's important to know. And each chair has 4 legs. The manager wants to be able to seat 36 people. So they have to have 36 spots for their customers to sit. That's what he wants to sit. The restaurant has hardwood floors and the manager doesn't want to scratch them up. So therefore, he has had to order 129 plastic feet covers to go on the bottom of the legs of the stools and the chairs. Okay, so each stool had 3, each chair had 4, but he's ordered 129 plastic feet to go on the bottom of the chairs. It says, how many chairs and how many stools did the restaurant order? Well, if it's asking us about the number of chairs and number of stools, that's what we're going to use for our variables. So we can use C for the number of chairs, and we'll use S for the number of stools. So now let's talk about our equations. Well, we have a total of something that they ordered, and we want to know how many total did they order. Well, think about how many people they wanted to seat. They wanted to seat 36 people. So they have to order 36 combined stools and chairs. So we know that a certain amount of chairs plus a certain amount of stools, it has to equal 36. So that's our total equation. Now we got to talk about the feet. Well, each chair had 4 legs. And each stool had 3-legged stools. And they had a whole total of 129 plastic feet. So that's going to equal 129. So now you have your 2 equations, and we're going to set them up and using substitution. Now, we don't have a single variable, so we'll pick one. I'm going to pick C, and I'm going to solve in terms of C. So I'm going to change this equation to be C equals minus S over here. I get 36 minus S. Now I have something to use for my substitution. So everywhere in the second one that I see C, I'm going to put 36 minus S. So our equation would be 4 times 36 minus S plus 3S equals 129. Go ahead and solve that. You're going to get what S is worth, which is the stools. You'll have to know the number of stools. Then you can plug back into that first equation and find the number of chairs. So your answer should tell me how many chairs there are and how many stools there are. All right, let's look at our last problem. Game ticket group sales. So we have tickets to a local basketball arena cost $54 for lower bowl seats, so some good seats close to the court, and $20 for upper level bowl seats, the ones that I could probably afford. A large group purchased 123 tickets, so a total of 123 tickets, and it cost them $4,262. Whew, that's a lot of money. So we've got to think about what 2 things we're talking about. How many of each type of ticket did they purchase? So we have lower bowl tickets, so maybe we use L for the number of lower bowl tickets. And we use maybe U for the number of upper bowl tickets. Or upper level, we could say. All right, so our first equation, we have to think about the total number of tickets, what makes up 123 tickets, and then we have to think about money. So we have one for money and one for total tickets. Well, we have a total of 123 tickets, and that's made up of some lower level ones and some upper level ones. Now, we have to think about the money. Well, we know that each lower bowl ticket was $54, so 54 for every lower, plus 20 for every upper, and they had paid $4,262. So there's our two equations. Now you're going to use substitution and solve. Remember, you have to find one variable to solve for and get it alone. We don't have that right now, so maybe we solve for L. So we're going to change this first equation to be equal to just L. So L equals 123 minus U. And now you have something to use for your substitution. So your equation would be 54. Instead of L, we're plugging in the 123 minus U plus the 20U equals 4262. When you distribute and solve, you'll find how many they bought upper levels, and then you can plug back in to find lower levels, and you'll know how many of each type.